Hello and welcome back. We are starting off this week's discussion with unit testing, integration testing, and end-to-end tests. So this whole week, this whole suite of videos this week are all about advanced testing and how we're going to do it, and something we had sort of alluded to earlier on. But just to start off today, we're actually just going to kind of take an overview of the different types of testing and how they affect our project. Let's jump into it. So first, let's take another look at this testing pyramid. The higher that we go up in this testing period, the fewer tests we should be writing. So the base of our pyramid here is going to be the unit tests. Those are the first tests we started writing in our project. They're small, they're isolated, they're fast. We can do full component testing even, so we can test a whole class or something like that. We don't really do component testing. We sort of jump over that after doing all of our unit testing, or we treat component testing like integration testing, which is what comes next right here. After integration testing, you'll see that we have our UI or API testing. So this often can be considered like similar to integration testing, because we could be doing UI to backend testing or to third-party API testing. So it's still sort of testing how components are like working together. And then at the very top, we have that manual and exploratory tests. So in between the UI API testing and the manual and exploratory tests is where we find like our end-to-end and system tests. These are often very heavy. Sometimes these can be automated as part of the UI testing level, but then on top of that, we still have some like more maybe complex workflows that we're testing, and those ones are done often much more manually, and there's fewer of them because they take a really long time, and they require human intervention, right? So that can take us some time too. So I've got sort of a breakdown here of a few different tests that we can see happening here. We've got unit integration, end-to-end, and manual. Okay, so unit tests, as we know, they're testing single function and sometimes for us a single class in isolation. That's why I kind of like combined component testing a little bit here. And they're very fast and they should be very reliable, we hope. And it's most of our tests, right? Integration testing, this is when we're making sure our components are working together. So component testing or intercomponent testing. And these ones may take a little bit longer because there are maybe database connections involved. So there's slightly less coverage at this level compared to the unit test level, but we still want good coverage of our code. Next is our system tests or our end-to-end tests. This is when we test all of our layers working together from the front to the back end. This doesn't necessarily mean that we're like showing the UI. It could mean that, but it also could just mean making like triggering a front end click without actually physically doing the click, just to make sure that the flow is as we expect as an end-to-end test. These are slower and they're often a bit more brittle. They're tied to our front-end components, and if somebody accidentally adds a component without an ID or changes an ID, they're kind of fragile. They break really easy. So we do have fewer of them. We just use them to sort of test that the flow of execution works as we hope. And then at the very end is when we have those manual or those UI tests. And these ones are valid, like these ones are validating the whole workflow through the UI, through the user interface. That's what I mean by interface here. These are slow, these are fragile, similarly to those end-to-end tests. And while we do, even in this course, write a few, in reality, we would write probably the same amount of them in like industry, because very often we have people whose job it is to do the UI tests, like a quality assurance person whose job it is to actually do those. They're not as automated. So a quick recap around unit tests. They're small, they're fast, and they're focused, right? So we're verifying the behavior of a single class or a single method in total isolation from the rest of our code. We don't want to rely even on databases, on APIs, whether they are our own APIs or third-party APIs. We don't want to rely on them. Or any sort of like UI, right? We're testing basically anything that lives in our in our business logic package. Often we're going to have a test target. We replace all of our dependencies, and then we assert. So we've got arrange, act, assert. I forgot what they were for a second there. Arrange our situation, right? Act, do the actual action that we want to test, and then assert that action. Next is this idea of integration tests, right? This is us asking, do parts play nicely together? This is when we can check multiple components or modules at the same time. We want to actually make sure that the connection is there and that the behavior we're testing propagated through the different layers appropriately, right? So this often does involve real systems, like connecting to our database and saving to it, or making files in a file system, or getting files from a file system, or even perhaps API calls to third party if we need. Here's a couple of common examples around them, like when our user service calls our user repository, we actually are testing the connection to our real database. We want to test that connection. There's the controller service and the data access layers, making sure that those are wired together. So making sure our controller and service actually speak to each other. And then a file processing logic, right? Like if you have to save files, or if we're writing something out or overwriting information, we can test those at this level as well. So here is the purpose, right? We want to verify real world wiring and config. That kind of feels like a tongue twister. We want to test against real dependencies, and we want to catch edge cases that we might have missed in our unit tests. Because even if we've sort of potentially mocked up as much as we could in our unit tests, right? We sort of isolated as much as we could. Sometimes there are just pieces that it turns out we don't feel like we can isolate right now. So we miss them in our unit tests, but that doesn't mean we have to miss them in our integration tests, right? Even though we miss it in our unit tests because we couldn't separate it out, we can just write an integration test for it and do our best to cover those edge cases in those situations. When we're doing this real world wiring, we're talking about things like our dependency injection setup. We want to make sure that we're doing that correctly. When we test on our real world dependencies, maybe it's our actual database, not just like a array list in memory, or the real file system on your computer, talking to it, connecting to it. And then when we're talking about this missed edge cases, perhaps it's things like null configuration files, transaction failures, things that we couldn't have tested without an integration version existing, like, oh, we're missing the config file, things like that, or a config file that's there but invalid. They're not end-to-end, they're not isolated, and they're not UI tests, right? We're talking about testing that seam. We're testing our seams. Our final type of tests are the end-to-end or system tests. This is when we test our whole application, imagining how a real user might use our application or misuse our application, right? So we have tests that should exercise the entire system from the UI or the API entry point all the way through all of the layers, all the way down to the real database, and then all the way back up. No mocks, no shortcuts, right? This is real world behavior. Perhaps we simulate a user logging in, placing an order and receiving a confirmation, submitting a form, verifying the confirmation screen, the database, make sure all the pieces are there, or running some test scripts through the full API or the full UI. Now, one very frequent question I get is actually targeting this first point here. If all of your tests start with simulating a user logging in, placing an order and or a user logging in, do we have to test that every single time? The answer is no. You can have a test that does that simulates the user logging in, ensuring that that piece works, ensuring that all those components are there, and then you don't have to keep doing that. And what that might mean then is faking the user logging in after that point, right? Just like it says, we can actually talk about just like getting in through an entry point instead. So maybe you just skip over the login for the other tests that would normally rely on it. As long as you have a user login test that actually goes through all the layers, checks in the database that they're a real user, passes the message back, and of course tests where the user doesn't exist or the user enters the wrong information, right? All of your edge cases, stuff like that, then you're doing the right thing. And it's okay to sort of skip over that so that you're not slowing down your tests. But we can't just skip that or fake it without also knowing that we have appropriately and robustly tested that user login. The other thing you can do is just log in and then not verify that you're logged in. You can verify if you want. It doesn't take that long to verify, but it doesn't have to be as extensive as long as you have a user login into end-to-end test somewhere else. Because otherwise you're just constantly writing the same code over and over again, right? You're just constantly verifying that you're logged in. That doesn't count as test coverage. You've already written that test somewhere else. So we have some trade-offs here on end-to-end tests. We have tons of confidence in end-to-end tests, right? Because they actually are real-world applications, but unfortunately they're very, very slow. They can take minutes long. It could be a person who has to do it, right? We love that they cover real-world behavior, but this does mean that they're quite brittle. If we have a small UI change, if the organization of the front end changes slightly, the whole test fails. Whereas stuff like that may not happen quite so easily with some of our lower level tests. And then these are great for CI smoke tests, meaning continuous integration, which we talk about in software engineering too. But it is a lot harder to isolate bugs at this level, because if something goes wrong and we see the message pop up on the front end, it could have happened anywhere along the whole execution path, right? We could have had the bug appear many layers deep as opposed to right on the UI. So it does make it a little bit trickier for us to sort of debug our own code and find where things went wrong. You can kind of think like that end-to-end test or these system tests are a bit like a dress rehearsal. If you or a sibling or somebody you know does any kind of performance-based art, right? They may not catch every single possible error that could go on, but they are still great to do before we get going, before opening night. So here are those three main layers that we sort of focus in on in this class: unit test, integration, and end-to-end tests. I've got a nice table here that shows you what each one should be covering and what we should be ignoring with each level. And we can see why our unit tests can be really fast, and then our other types of tests are quite sort of slow and then even slower. So draw a pyramid of your own project's test suites. And do you find that you have tests at each of the different levels? So go ahead and draw yourself out a pyramid. It's okay if it only has 3 levels, the base being unit, then integration, then end-to-end. And go and check that you have tests at each level and see if you have any gaps. See if we're missing any classes or functions, any functionality or behaviors, any features. Is anything missing from our test pyramid? So that's the general overview that we're looking at when it comes to our test suites. We're going to sort of dive deeper now into different libraries and ways to sort of hopefully make testing a little bit easier, and talk about some of the trade-offs of using different libraries to help us with these tests as well. Okay, thanks everybody, and I'll see you in the next video. Bye.